Anyway, let's continue, okay? Yeah, I did not log it out. It's always automatically logged in. Maybe that's impossible, but I will check after this session, okay? But now you can see me, right? You can hear me now, right? Okay, so let's continue. Yeah, this kind of technical problem is very annoying. Sometimes we just have no idea at all. Okay, anyway, so for this one, that will be summation of these four. That will be summation of these four. 1, 2, 3, and 4. All right. Now, by this one is maximum of them. So the one that grows the fastest. For any polynomial function, it's quite obvious. C is big O of n C plus 1. Degree, the one with larger degree grows faster than the one has smaller degree, of course. So this one is very useful. We can just throw away all the other things. So just simply get this one. It's very convenient to use, and this property is very useful. And it's very easy to prove this one, of course. It's trivial, all right? So that's the first important property. The second property is dealing with the product of these two functions. Then we can just use the product of their upper bound. Their upper bound. Again, it's very simple, but it's again, it's very useful. For example, we have so for this function, so we can just simply use upper bound for these two. So this one upper bound is n cubic. Use first property, we know that use first property, this one is n squared. So that gives us order of n to the power fifth. Okay. Again, it's very simple, but it's very convenient. And finally, a combination of functions. So the combination of composition of function. As a result, as you may guess, just replace f by g. That's it. So these three properties are very useful and very handy to obtain upper bound of functions. And so let me give you an example. For example, this one, that's a combination of function, exponential function with polynomial function. So this, what we need to do is just get an upper bound for this in this case. Here, maybe change it to something else. Okay, maybe also a different function here. Let's see. Yeah. So suppose it look like this. So this one is upper bounded by n cubic. Here is the n force. So that gives us this one to get. For this one, let me see. Maybe you need to be careful. Exponential function. Oh, it's okay. Okay. So then again, this one can be, no, this exponential function need to be careful. Need to be careful here. So actually this, you can simplify this one to be n order on n3. In this way is okay, but not this way. Okay. Not this way. So need to be careful with exponential functions. This one, I can further replace it, but then its notation should be like this, but not this one. Exponential function. Okay. Okay. All right. Now for some further refinement about the ordering. Okay, for logarithmic function, the base does not matter. So any logarithmic function have same growth rate. So whether the base is 10 or natural logarithm or base 2, so that will be same as base 2 in terms of growth rate and same as natural logarithm. So base does not matter in terms of growth rate. They only differ by constant. All right. Remember the formula for base change for logarithm. So because that one is only differ by constant. Okay. Now another thing, as I mentioned, as NC1 is always bounded above by NC2 whenever C2 is at least a C1 for polynomial functions. So that's 1, 2. Okay. Now for exponential function, the larger the base, the faster function grows. Of course, we know that one. So for exponential function, that's always the case. But we also need to remember one thing. For exponential function, so here I use a note here, A2 and not bounded up A1. The growth rates are different. So that means A1n not same as A2n whenever A1 not equal A2. So in terms of growth rate, they're not very different growth rate. Okay. So that means 2n, 2 to power n is always bounded above by 3 to power n. But this one does not hold. So this one does not hold. Maybe better not use the notation here. So this one is incorrect. Okay. One more property. Logarithmic function, regardless of how many power we raise it, it's always bounded above by a polynomial function, regardless of how small c is. So here c of course is the b is regardless of how small this one is. So for example, maybe take usually in computer science, usually base 2 is very often. So here base does not matter. I think let's say base 2. Okay, pay attention to this one. This one is log to power and raised to 100th power. Here is polynomial function, but it's power exponential part very, very small, 0.00001. But regardless of how small it is, this function is always bounded about by this function when n is large enough. So for this one, I think n will be quite large. N is quite large. So you can compute it. If it's a base 10, so that will be like a million or something. Okay, not less than a million actually. Because here 2, 2, 3, 10 to the power of fifth, 100,000. All right, but regardless how small the c is, regardless how big the t is, polynomial of logarithmic function is always bounded above by polynomial function. In particular, very often we use this one. This one will be used in practice. Log, say t n equal odd of n of linear function. Very often you may see that. Actually, you won't be able to this one very often. At most, you see log n, log squared n squared, log n t. Most of you will not see it. Very few will see it. Will meet this one. All right. So finally, let me just try to combine these things together. Give you maybe I can call it a template, an ordering of some common functions, and then you were able to use them to determine the ordering of functions in terms of their growth rate. All right. Always something. Oh, I have about a few more minutes. All right. So let's see. Okay. So unless you are going to do very serious theory in computer science, the following ordering will be good enough, will be more than sufficient for all of you, for maybe 99% of you. Okay, the following ordering. Just basically a combination of three important functions. So we have at bottom maybe logarithm. Then we have polylog. And so on. Okay. Then we have polynomial functions. So maybe n to 1/3. And yeah, square root of n. So that's cubic root. Okay. Let's write maybe in this way. All right. So then will be linear function. So this particular function called the linear function. Then we have a combination of linear function and logarithmic function. So this one you will see it fairly often. So of course, this one will be no more than n squared. Okay, the multiplication rule because of this one, so we have this one. All right. Then we get to quadratic function. That's called the quadratic function. All right. So then, of course, we can have combination of this one with logarithm and so on. Then we have a sequence of polynomial functions, of course. So n cubic, n to power 4, and so on. All right, now we get to exponential functions. It's always bounded about by exponential functions. So the base can be very small. Sometimes we do have very small base. For example, 1.1 to power n. Okay. So then when base grows, the function grows faster. So 1 point maybe 5, 10. And we have this very typical exponential function 2 to power n. That's the one we see most often in terms of exponential function. Then we have, of course, different base, so 3 to power n and so on. And eventually we may have n factorial. That's very fast. And then n to the power of n. I think that's good enough. Basically, you only need to remember the basic thing, right? So here it's let's see, maybe these things. And these act like cornerstone. So these things maybe. If you want to remember these things, I think that's good enough. Okay, in the middle, it will be easier to fill these things in. All right. Okay. Now let's work on a particular example. I give you some function, try to order them by using this one and the previous properties, the properties of big O notation. Once you understand that, then that's good enough. It will be good enough for us. Okay. So let's consider a few functions. Okay, I think logarithmic function, maybe add one logarithmic function. Okay, so just 6 functions. Try to order in terms of their growth rate. Which one grows fastest? Which one grows slowest? All right. Of course, we can simplify someone first. Some of them first. For example, this one is n cubic. So this one can be simplified to 2n. This one is the leading term, right? So these two ignore it. So this 2 to n. All right. Now after simplification, so here is n squared. Log n squared and 100 to raise it to 100 pounds. Log n squared equal 2 log n. So that's logarithmic function raised to nth power. So this one grows slowest. This one grows slowest. Then polynomial function. So next one is polynomial function, this one. N cubic. Oh, sorry, this is linear function, I forgot. The linear function here. This one is odd n. This one is only odd n. Linear function, of course. Maybe use 1, 2, 3, 4. It's easier. 1, 2, 3. So then we have exponential functions, 3 exponential functions. So in terms of base, this one is smallest, this one is larger, and this one is the exponential function times the polynomial function. So this smallest, 4, 5, So that will give us ordering of these functions. Okay. So let's have a break. I don't know what's going on with Zoom. I maybe during break I try to check whether it will happen again. I don't know. Okay. So okay, let's have a break first. After that, we'll go back to the constellations. Try to solve the constellations arise from algorithms and use big O notation. Okay. Okay. So see you in 15 minutes. Oh, okay. Midterm exam time is should be November. I will announce it. It should be November 2nd. But the time actual length of exams, these things haven't decided yet. The problem is because there are 4 sessions. So they try to the faculty try to coordinate these things. So that slows things down a lot. Okay. In terms of homework, actually. For homework to submission, I would like to ask your favor to do a test of system capacity on Wednesday. So I will not open submission until Wednesday. I will tell you when to submit. I want to see how fast, how well the system does to prepare for the midterm exam. Because our online exam eventually have to submit through online system. Okay, so I want to do a test on Wednesday. So I'll also announce it on the course homepage.